Hi guys, yeah, welcome back to the new session of operating system programming concepts. And for today, I'm trying to solve the exercises that are related with laboratory 8. All right. So before beginning, I will just specify some learning goals for this laboratory. And in this laboratory activity, you will learn how to synchronize two processes by using pipes. As I have already told you guys how to use the pipes, right? The pipe system called in C programming language. So we'll try to synchronize by using the pipes, and you know that pipes takes file descriptors, all right? And we'll discuss this. And you'll also improve your knowledge about the Bash shell, you know, the shell programming language, Born Again shell, the most popular shell programming language. Whereas, moreover, you'll also practice and use and see the magic of grep, find, unique, WC, TR, translate, and code commands. All right. Okay. So now let's begin our exercise 1. And exercise 1, it says that write a C program in which a parent process creates two child processes, a producer and a consumer. I have already solved one of these problems, right? Like producer and consumer using a system called like using signal for synchronizations, right? The signal handler was also there, which passed the signal. So the producer reads the line of the text from the standard input and writes them to a pipe. So pipe is like producer is producing lines of text. So in the standard input, so it's like a file descriptor. Okay, one of the file descriptor is used by the producer, and the consumer process reads the data from the pipe and writes them to the standard output. So the idea is like the second data, like file descriptor, is used by this consumer process. Okay, to read the data from the pipes and write them to the standard output. So the situation is like converting text line to capital letters, and the idea is the algorithm is just to convert the text line to capital letters, and introducing the end string terminates both the child process and the parent process. So all right, so let's see the situation, that let's investigate or let's solve the situation. Okay, let's close this. And what I have done is I have already solved this particular problem. Alright, so what I show you guys is this one. Okay, I'll just go through it. Like line by line. I will just try to check it out what's going on. You guys know that we have to include all those header files that are standard input or output header files, the library header files, the C type header files, string header files. C type is almost not necessary. Okay, you just can use the Unix header file, standard header file. These are important things, whereas signal header file are important in system. Wait dot header files are also important. And you know, like we define a maximum number, that is 132. And lastly, the sender and receiver are also the functions. We declare the functions. The sender and receiver are like producer and consumer situations. All right. And in the main function, what is done is like, look, you declare a file descriptors of array size always 2, right? And then the child process ID and the status is also here. The receiver, like you also declare the variable, that is receiver PID, process ID, and sender process ID. Now you call the pipe, you pass the file descriptor, the pointer to the file descriptor. That means that is array. This is the address of this file descriptor. And secondly, you receive the receiver is going to fork. Alright, so what is fork? Fork is a system call that creates child. Okay, and if receiver PID, if the fork is 0, that means you guys know already that this is a child, and the child, what it does is child receives. Okay, the receiver function is called here. Alright, and we pass the particular file descriptor here, the address of the particular file descriptor. And secondly, otherwise this is a parent. So being a parent, what it does is going to send. Okay, send. And also here, secondly, we also fork creating a second process, that is a sender. Okay, so if a sender is 0, that's a child. This second fork, that is creating a second children, is going to send the particular message to the receiver. Okay, so look, it is sending to a receiver with this receiver PID, and the file descriptor is also passed as the second parameter in this function. And lastly, we print out the sender and receiver process ID. And lastly, the child, the main parent, is going to wait for both the child for them to change their status. So it's waiting 2 times, right? It's waiting for 2 child processes. That means one is the receiver child process and another is a sender child process, right? So here we are creating 2 child processes overall. And lastly, you are going to send this. All right, so okay, let's now extend this sender function. What we are going to do in a sender? What's the second child is going to do? The second child process, this is going to send it to the message to the receiver. So firstly, what we define is we define the variable that are the lines of the maximum size n and the temporary character array of characters, whereas the sent message, the counter for the message sent is also initialized to 0, and the sender PID. Now we close the function. Okay, so what is close doing here? Go and check. Close a file descriptor. It's said here. Closes a file descriptor. It's just going to close this file descriptor. Alright, it's included in the standard header, Unix standard header file, and closes a file descriptor so that there is no longer refers to any file and may be reused. Okay, so it's just used to just it is like refresh so that you can reuse it. Okay, it's just like all the like it has no reference to any other file, so it is a fresh file. Alright, so sender PID, you get the PID for sender. Now while looping forever, while always true, what it says is like it prints the sender PID, it flush. You guys know that f flush is going to just flush the standard header, like standard output. So let's close none of f flush. Yeah, flush is a stream, so all the input streams are flushed. Okay, now it scans for the line, because we have declared a variable line of maximum size array n, and you just scan for this from the standard input, all these strings, okay, in a line. Then you print out the sender PID and the strings it is going to send, right? And it writes, what the sender is going to do is writes the particular the temporary pointer, like the what is going to write is inside the file descriptor. It is going to write the message, sorry, I have already gone through all these things. Sends a message to another user. It is just going to send the message to the another user, and here I am specifying in a function what is going to do is just going to write something in this file descriptor, okay, of maximum size. This one string length of this temporary file, the maximum size, it writes of maximum size this one, and it starts in this pointer, that is temporary pointer. Alright, and now it increments the message, okay, and it checks is it in the end, has it returned the line, has it returned the end. If it reaches the end, then it just breaks the execution process here and just sleeps for 1 second, and lastly it finishes. And you can also sleep and exit, okay, send message. And secondly, for receiver, it takes the second file descriptor. It also similarly does the same thing, like it scans first. Actually what it does is it scans, and then lastly it going to read, right? It's going to receive. So it's just going to read, it's going to scan, okay, it's going to check has it written at the end, and lastly it's going to also convert it to the uppercase from lowercase. The algorithm was the problem was just to convert all what it is receives as a message, to convert it from lowercase to uppercase, like so. Here this function is used to change it to the uppercase, and lastly it prints out uh, and it's increment the counter of the message received, and it's all done, it exists. Okay, so this is the basic way of like solving this one of the simplest way of you solving this producer and consumer problem, like the sender and receiver problem. And now also I have a second solution, okay, which is this is done in a different way. And okay, let me also just give you one overview or idea of this second solution. And the overview for this is also the concept is same, but the only difference here is we are using also a signal here, okay. As you guys already know, to synchronize we are using here a signal to synchronize. We are not using wait, because before we like there was a wait system called to synchronize, right? But here we are using signal to synchronize. We send the particular signature, this particular signal to the signal handler to handle the signal. And similarly we also create two child processes, that is receiver and sender. And the parent process is going to wait for this both child process to change the status. And you guys know that how to handle the signal, right? Because how to install the signal handler, I have already gone through these topics before. Here is the catcher, okay. This is the signal handler, and it just returns, okay, it just returns. And secondly, for we have to go through, there is a sender and receiver. So let's go extend the sender. What is sender doing is taking the receiver's PID and the file descriptor second. So all the variables are declared, and the important part is like while true, what is going to do is first you guys have to understand that it performs its action, okay. All the actions are performed here, like it flushes or prints or scans for the particular or writes anything, because sender is going to write. Actually the key concept you guys have to understand is sender is always going to write or send something. Alright, so it's going to write something, so which will be read by the receiver. So here all the actions are performed first, and then you, after actions are performed, you increment the counter to just specify that the actions are performed, okay, how many actions are performed, just to specify that particular situation. And lastly what you have to do is you have to send the signal, okay, that is by using this system called kill, okay. So this particular signal that we have created as a signal handler will be sent to this receiver PID. So signal is sent to receiver, this signal is sent to the receiver, okay, with this. And then the pause, so it waits for the signal from the receiver, sends the signal and waits for the signal from the receiver. There is three concepts: performing action here, send the signal, and wait for the signal and execute. This is the thing done by the sender. And lastly, secondly, here the receiver, what is going to do, all the variables are declared here. While forever true, it waits for the signal. Firstly, it waits for the signal from the sender, that is this sender. Okay, after the signal is received, first you have to wait, then you perform the action, that is reading and just performing anything like changing from uppercase to a lowercase, or doing any kind of things that is given by your numerical program. Okay, and then it sleeps. After performing the action, it sleeps, then increments the counter. Also, this is the action light, and lastly, it sends the signal back to the sender. Right? And this is it. This is a simple way of solving this kind of solution, like problems that you guys will see. Okay, right now this is all up to the problem number 1, that is exercise number 1, how to solve this kind of process, how to synchronize this child process and parent process. Now let's go to exercise number 2. And in exercise number 2, there are the situations like you are given this file with these following attributes: products and quantity, books and the quantity information, and then what you have to do is sort the data in reverse order by first field. Alright, so okay, let me go through these situations now. Here what it says is sort the data in reverse order by first field. So let's see if we have this particular data. Yeah, maybe input.txt. Yeah, so this is the file, right? Here you can see here. Now we have to sort the data in reverse order by first field. So what you do, sort. So to specify the field, it is like, okay, we have specified the field, and what you have to do is sort in the reverse order. Okay, sorry for that, because I have to also give the input file in the reverse order. Then it's the input.txt file. Is it okay? So it's just reversed, right? Pencil 2010 43832, right? It's just reversed, and that's the situation. So sort the, now the second question says that sort the data by second field quantity number. So also the quantity is already done here. It's the same actually. Alright, sorting by specifying first field and the second field, because it was already sorted enough in the situation that was given, but it's not sorted because here you can see as 438 is coming here. Okay, now let's do that situation. Sort second field. Okay, so you see that there is some extra thing, right? Product quantity. So to remove such kind of situation, what we have to do is you just sort it. Okay, sort it numerically, and then you pipe it to, and what you do is grep sorry, pattern was, what is the pattern is, entity, and how I sort it. Yeah, this is all sorted right now by using this command. You guys can see here books 2 3 3 is sorted in a reverse order, 2 3 like in a ascending order, like 2 3 3 4 8 10 20. Okay, I'll also show it again for your clear information. 2 3 3 4 8 10 20. And grep minus v is used to just not select this pattern. Okay, it's just to remove this pattern, so that we remove these situations here. We just display the sorted items. Alright, now let's calculate the total number of books. And here is a hint given, that is use this paste minus sd plus not this minus actually slash bc. Okay, you guys can use this command to count the number of situations. So total number of books. So how can we calculate total number of books? For calculating total number of books, what you guys have to just do is just grep for books. I mean, let's grep for books. Alright, you can see this situation. Just books are grepped. Now, after grepping for books, okay, so what you do is cut the second part field. So the field will be specified. Okay, the delimiter will be space and the field will be second. Alright, so after you got it, let's see what's the situation. Yeah, this is the situation. So now you again pipe and use your command, that is paste, that is given as a hint, st plus paste st plus and pipe to bc. Yes, 13. So if you add here, the books were 3 to 8. This adds to 13, and this is the solution of total number of books. Alright, so now let's go to the fourth situation, that is print just the list of products in capital letter. List of products in capital letter, and each kind of products has to equal just once. Okay, that means only one time. Okay, so for this kind of situation, what you guys have to do is like you list of products. Okay, first grab the list of products, cut delimiter, field is 1. So when you sorry, okay, you have to also pass input.txt. Yeah, these are the list of products. Right now what I have to do is just sort this. Okay, let's do it step by step so that you guys will understand. And after grabbing the products, let's grep deselect this product, that is product. Okay, and I just want to sort them. Okay, you can see that it is sorted. Now just use the Okay, so now the idea is these books are sorted and the products is also, this is removed, we don't want that. Okay, sorted. Now after the sorted products are using unique okay, let's see that what happens if I just pass the unique one. Yes, so you have the only unique books, so only those repeated books are just ignored and only one book is like displayed, right? Even these pencils, these were repeated and only one were displayed. This is the function of unique command. Now what you have to do is you have to just change it, translate it to small lowercase letter to the uppercase letter. That is it. Okay, so this is it. Books, pencils and pens, they are all in uppercase letter. So this was the whole answer of all the this of this question. This was to just print just the list of the product in capital letters. Okay, our text, our main text was this one. From this text we grabbed this solution, right? Okay, for exercise 2 we are done. Okay guys, right now for exercise number 3 what we have to do is we have to write a bash script. Okay, and this bash script is going to read 3 command line parameters. Okay, a directory, a file function name and a name of the output file. So you have to write a script such that this script has to search for all the files in the directory which contains the function passed, and this function is passed as a second parameter, and lastly it must output in a third parameter, that is we pass as a output file. All right, and what you output is like you print the name of the file, the matching line number and the matching line itself. All right, so results must be sorted. Okay, this will do, the sorting part will do later. First let's print out the situation. Okay, to do that let's go back to the terminal and let's see that the situation here. Okay, so we have a test.sh file here, so gedit, or we can move, or we can just remove this test.sh. We can create new this test.sh file. Alright, so this is a cell file. What I am going to do is I am trying to write a new bash script here. So first I comment it to my bash bin.bash, this folder, that, and say that to this system that this must run from this path that is specified here, bin.bash, and others are used for commands, right? This, okay, comments, I mean not commands. So now let's check. Firstly what we have to do is we have to check for the parameters, are they passed, are 3 parameters passed. If not, we have to check, condition check 3, if we pass only 3 parameters or more or less or greater. Okay, so if this total number of parameter pass is not equals to 3, then what we have to echo and say is that wrong number of parameters passed. Alright, so then also you exit, then we close the condition check. Now secondly we have to do for the loop, so we have to loop and check among all the files in the directory for the pattern, right? So we have to loop in this directory and check in the directory. So let's use this find command to find the folder files in the following directory. So the directory will be passed as the first parameter, and we find for type is a file. So after going for a loop, what you have to do is you have to check for the parameter, okay, that is a function that is passed as a second parameter. So what you have to do is grep the parameter pass, the patron is a passed as a second parameter, and we check it in a file. It is a, this is the variable for each this one in this value. So for all this value, each time it will take one, and it will just loop from one by one for all the files that is found. It will just loop once and 2 and 3. Okay, so here is passed as a parameter, and then it says that you have to print out the name of the file, the matching line number, and the matching line itself. This is going to print out the matching line itself, but we have, okay, let's check for the, okay, I'll show you here in our terminal. If you go to the main of grep, you will see that the options to print out the matching file, yeah, this option minus capital H will print the file name for each match. So we use this option to print out the file name for each match, and here the line number. Okay, so this will print the line number for each match. Let's quit this, close the terminal, minus n. Alright, this is it. We pipe it to sort and then append it to output.txt. No, this output, it will append it to the output file, that will be the third parameter. Alright, and this is it. This is how the this is the bash script for finding the patron in the past directory, and output just append it to the third file that is passed as the third parameter, right? Output whose name is present in the third command line parameter. Okay, so now let's check it if it is going to run or not. Yeah, we have this test just SL, so let's make it executable. Yeah, it's now executable. Now I will show you my directory that I'm going to pass as a parameter, that is test directory, and it has 3 files. And if you check out txt, it contains of this thing. Also there is ho, right? Cat bbb.txt, also this contains of this one, right? Sorry, it consists of 3 files that are AA, BBB and CCC. So cat ccc.txt equals to, also it contains 3 files. This text and consists of also ho, something like this, right? Now let's change the directory back to our working directory, and now what we have to do, we have to test, and we have to execute passing the executable file, passing the parameters that are, first is test, second parameter is the patron, that is ho, and third parameter is where you want to output.txt. Okay, before outputting, let's check that is output.txt empty, or cat output.txt file, this is empty or not? No, it's not empty. Okay, so we have to just make it empty. Cat output.txt, we do not get anything. Okay, now we check that is it empty or not. Yeah, it's empty. Now we execute this executable, pass the parameters that are, what are the parameters? Are the test folder directory, and then the patron, that is ho, and the third parameter is output.txt. Okay, now let's check if this consists of those files. Yes, it consists of those files, all those files. Look, the file name and the line, matching line number, that was 1 in this file, that is B, and O is the line that is printing out. Whereas secondly, for a text file name, the matching line number is 3 and the corresponding line is printed. Everything is printed here, right? So even the matching line number for this C file, ccc.txt file, similarly, this was the problems that you have to display. Okay, so you guys can sort it anyhow. You guys can sort it either by this way, or like sort it the delimiter will be dash, because we want to sort on the basis of the file name, right? So this will be the delimiter. The field will be second, and let's sort it in a dictionary way. And our file is output.txt, right? Yeah, it's sorted now. A, B, 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 C, C, C. And similarly, it's also sorted here numerically, that is 3, 5. Okay, and 1 and 1, 2. Okay, numerically and alphabetically sorted. And this is it for how to solve this exercise 3. But you guys can also, what you guys can do is gedit test.sh. Okay, you guys can also append here as a sort. You can sort here, or you can sort and also pass the parameters, right? Like the field is this one, this one, and no, it was the delimiter was this one, the slash, right? And the field is the second field only, and we sort it on the basis of the dictionary. Sort is done there, and lastly we append to the third parameter. Alright, you can also do in this way. Okay, now let's close this, and now guys, let's go to our fourth exercise. And what it says is, let's first clear this. Okay, our exercise number 4 says that write a bash script that gives a file given a file name as a command line parameter, prints the length of the longest line of the file and the total number of lines of the file. Suppose each line does not contain spaces. So this is just for extra information, but what you guys have to do is write a bash script that given a file name as a command. So how shall we proceed in this proceed to write this bash script? Okay, let's begin. And yes, let's remove this test.sh file. There's no more there. Again, let's create it. Alright. Okay, so this is our exercise. Now we have to write the bash script, that is by writing a special command to our system, that is it must start executing from this bin on the bash folder, and here given a file name as a command line period prints the length of the longest line of the file. So let's first use the variable, that is I, the counter equals to 0, the max equals to also 0, the absolute, this is something, this is 0, and what is done is while you read a variable, that is you read a line from this file. Okay, while you read a line from this file, and what you have to do, if you now test it, say that this do not test it. We have to. Okay, let's wait and see what we can do. We do not need to test it. We have to. Okay, assign a value to the variable, that is the not this variable, to this auxiliary. Alright. And what is this special command that I am using? Dollar plus this curly bracket and passing the parameter. I will show you this thing. To go and check out in the terminal, and this is for bash. If you go deeply and investigate about this command, this particular, you will see some situations like that. Okay, let's go with just try to understand this. Okay, yeah, you guys go through it. Let's investigate it and see where is that. Try to just specifically show that this manual is very big. No, it must not be like this. So okay, it is just here. I form it out. Yeah, okay. Yeah, it was just up here. Okay, look, if you go and check out the manual, you will see that dollar has parameter length. What is going to give you is whatever parameter you pass here will be, this will specify or give you directly the length of this parameter. Alright, the length in the character of value of parameter is substituted. So this will substitute with the length of the character of this parameter class. Okay, that I was doing the similar thing here. So auxiliary, this variable will consist of this, the whatever you read here, the length of this line will be passed in this value. Now secondly, you check here, if you test this auxiliary is greater than max, then we have to assign this max with the auxiliary, right? Now close this, and we have to also increment the counter by saying I equals to, you have to say something like I plus 1, increment the counter while, okay, so I forgot one special thing that you have to do, and lastly you have to also turn situation here. Okay, just don't forget that. And lastly what we do is echo, and we say that what we have to print here, print the length of the longest line. The length of the maximum line is with $max, and secondly the total number of lines in the file dot total number of lines is $5. Alright, so I think this will solve our exercise, and let's save it and let's close it. Okay, after that what you guys have to do is, now let's check it. Let's check the situation, test.asset. Let's make it executable, change mode, test dot, add the executable permission, then check it. Yeah, it's executable now. Reset, and you have to pass. Okay, sorry, I forget one thing now. That is, I have to pass also the parameter, right? So I haven't passed the parameter, and let me go back to the file, and what I have to pass here the parameter. That is file, that is first parameter here, like this, right? You append like just standard input the parameter, then still okay. Now let's execute it as such, and let's pass the parameter, that is text dot sh. But before that I will show you what is inside text dot sh. No, text dot txt, I mean get text dot txt. This is our parameter word. This is our text file which consists of such following text. This is the maximum length, and similarly. Okay, now let's execute it. Text dot sh, pass the parameter, that is text dot txt. Yeah, look, the length of the maximum line is 324, that the following line that I showed you before, and the total number of lines is 12. So okay, there are 12 lines here. If you count here, there are 12 lines, and the maximum length is this one. Alright, so this is our second, like fourth exercise. Now we have, this is our last exercise which we are going to solve in this laboratory right now, and this is like we have to consider the following fragment of codes. Okay, and what you have to do is you have to draw the process creation tree. I will not show you how to draw, but the idea is, I think you guys already know, there is the precedence graph, right? There is a process, parent process, and two process are synchronized by using the arrowhead. Alright, the process is thus represented by using the means of a circle. Alright, that was it. Now try to figure out the output of the program from the different execution, then execute the program and compare with the with your result. So what shall be the output of this following program? Can you imagine? Can you just think about it? Okay, as I have, with all the prior information that I have given to you guys, that is for this process, and look here, we are creating process in a loop. Okay, so what can be the result? The result can be, it's looping for 0, 1 and 2, so it's looping 3 times, 0, 1, 2, so 0, 1 time, second time 1, third time 2. Okay, and also it is forking, so it's each time is looping, is creating the child processes. So it's creating 3 child processes and an identical copy of its parent. So altogether it will be like 6 processes. Okay, so for the child process, it is going to okay, if not fork, that means it's a child process. It is going to execute this, all these statements, and otherwise it's going to increment and execute in case of the parent process. Each time is forking, that is 3 times it's looping, and each loop is creating 2 child processes. So altogether it is 6 child processes, and look, following statements are printed like executed for each processes. So let's see what is executed in the child process. Is you print out this running standard. First you print out this. If f plus standard out means it's just you are emptying the standard output, and you execute. The child process is going to use this exec system call, and the family of function is exec lp. So it's going to echo just this I into I. Alright, and I dot I is not passed any parameter, so I dot I into I is printed out. This is terminated by null. This exec statement is terminated by this null exec system call. All the parameter classes should be terminated by null, right? I have already provided the detailed information about how to use exec before in the previous lecture. So here what you have to do is implement the counter, and similarly you in the second, that is the parent process, you have to standard output running system, and your system is you echo out I plus I. Alright, and that's it. So what it is doing is, first it is print like echoing out I into I, and second is echoing out I plus I for first process, for the counter 0. When the counter is 1, again is going to print out I into I and I plus I. And again for third count, that is I equals to 2, it is out again printing out I into I, echoing out I into I, and again echoing out I plus I, and similarly. So it is going to echo out 6 times, and following information will be echoing out. First will be the child process, and the second will be the parent process. Okay, now let's check it by using our main program. Let's copy this. Paste this. Let's include the header files that are standard IO, the header file, and include the standard library header files, and include the unit header files, unit standard header files. I think this is okay till now. And similarly, what we have to do is edit this. Okay, so now let's check it what's the situation, what is going to like. Let's compile and run it and see what is printing up. Oh sorry, the return must be somewhere here. Alright, yes, you guys can see just return 2 times. I don't know why it do like that, because it depends on the time of compilation. Illusion of here is like parent is executing before all the child processes are executed. Okay. In this particular case, it will be very difficult for us to see the result. terminating definitely alright, not only times 10. Problem is fast. Okay, it's not waiting for other. It's because I'm just returning 0 in the while loop. Okay, it must work well. You guys can. I look 3 times it's printing out, right? First, this is the child, and second the parent. First again the child parent. Altogether 6 processes, 6 execution were done here. The error was because I just returned here when I was inside the parent the first time. That's why it was returned. Okay, so similarly, if you see here 4 times, like it will get 8 children. 1, 2, 3, 4, altogether 8 times, right? Not 8 times, because it will be also 4 is also included, so it will be 5 times. So 5 into 2 is 10 times. 10 processes will be created. Alright, so this is just for your information. This was just the review of our old exercises before. Okay, so lastly, for summary, you can see that at the end of this laboratory, you will just understand how to synchronize 2 processes by means of pipe, right? And you also understood the magic about find, grep, wc, sort, card sort, translate, and unique commands. I think right now you guys can just solve the simple like examples by yourself, right? Okay, this is it for our this session, and I'll be back in the new session. So thanks for listening.